Through this lesson, so hopefully there's no major interruptions. Okay, in this first example, we are talking if you were to, okay, years since 2000, that's what those stand for. So what year corresponds to 0 years since 2000? That would be the year 2000. And 9 years would be 2009. But they're not always that easy, so you're going to have to pay attention. Sometimes they give you a random number like 2007, and then 0 would be 2007, 1 would be 2008, and so on and so forth. So make sure you're paying attention to that. Now, number 2 says, if the data were displayed in a scatter plot, what would the scatter plot show? A positive, a negative, or no association? Remember, positive goes up, negative goes down. No association really means there's no pattern to follow. So if we take a look at this, there's 2 places where it's kind of tricky, but other than that, there's a definite pattern. So the 2 places right here, $2.81 to $2.65, and then 288 to 270. There's 2 places where they essentially dip down, but generally speaking, they are all going up. So I would say it would be positive. Most show an increase. Show an increase. All right, now the last question they ask you, without even showing you a scatter plot, they ask you what would be a more reasonable prediction for 2015. $3.25 or $4. So if we look here, in 2009 it's $3.24. 2008 is $3.17. Now, in 2015, that'd be 6 years from now. I would definitely say that $4 would be more, and my reason would be because 2009 is already $3.24. Excuse me. Okay, so today we're going to continue with our line of best fit. You hopefully got your foldable done. For a line of best fit, when you draw one, you are going to be putting it right smack dab through the middle of most of the...
Sorry, are we just doing L's?
Yeah, we're going to finish lesson 2.
Okay, can I just get that in class? Okay, thank you.
All right. So when you pick a place to put your line, you want to put it right smack dab kind of in the middle of all your points. You don't want to be above all your points or below all your points. You kind of want to be right in the middle. And so know that every person might draw it a little bit differently, and that's okay. That's okay, because it is an estimation. It is not an exact science. All right, so down here, they actually took that data from the cookie dough prices, and they graphed it, and they drew a line of best fit, which is kind of nice, because then we're all kind of in the same boat if we're following the same line. Notice their line of best fit. It's kind of right smack dab in the middle of all the points. There's about 4 above them and about 5 below them. Okay, so the y-intercept in this would be about, $2.55 or $2, maybe 54, whatever. But what does that mean? What is that y-intercept? When we made the foldable, we talked about the y-intercept being the starting point. Well, more specifically in this case, it's the starting price in year 2000. So price in year 2000. You're fine. Okay, then the slope is always a rate of change. Now, we want to be more specific than that. A rate of change for this particular problem would be the price increase per year. All right. Now, number 2 says, use that line of best fit to make a conjecture about the cost in 2013. So we're right here is 2013, right? About halfway between the 12 and the 14, obviously. And the price there, according to that line, you have to go to where your line is, and it would be right at about $3.35, I would say would be a good one. Now, obviously, depending on who draws the line of best fit and where you're at, yours might be different. So you have to follow your line of best fit. Let's see what I'm talking about that over here And this one, on slide number 4, they give us, really honestly, in my opinion, a very ugly scatter plot. Then they ask us to draw and assess. Don't pay attention to the assessing the line of best fit. Just draw it, because assessing it is deciding how good it is. Well, if you are drawing a line of best fit, that's because you choose to put it there because you think it's the best one. So obviously your assessment is going to be, hey, it's pretty good, because otherwise why would you put it there? Okay, so now this data, this is what I'm saying. I don't really like this data because it's very, very open to interpretation. Now, in my opinion, you see, I like this line right here. However, the problem with that is if I keep going, it kind of looks like it tailed off. So I don't want to draw a line through those points, but maybe right smack dab through the center of it. Okay, now my line might not look like your line, but when it says use that line of best fit to make a conjecture about 2015, I have to use my line. So 2015 is right here. According to where my line is, or wherever yours is, that's the price you're going to give. So mine is going to probably be about 6,600 points, right? But it will depend on where you put your line. Okay, keep going. We're going to slide to the back. Notice on this one and on your assignment, I will give you problems, a lot of problems. If I'm asking you to write an equation, I'm going to give you the line of best fit. It won't be one that you draw in. Okay, so when you're writing an equation, what you're going to do, follow those rules we did yesterday. I would pick 2 points. So in this one, probably this point and maybe even, let's see, where's a good one? Maybe this one? No, I want to deal with integers. So let's go right here. So this point is right at its 2 years, and I'm going to say it's about 130. Now, notice my word about. So do you see why everyone might get something a little bit different? Yes, okay. And this one right here is at 7 and probably also 230. So that works out pretty nicely because finding my slope, because that's step 1. Step 1 is finding your slope, 230 minus 130 over 7 minus 2, well, that would be 100 over 5. So my slope is 20. 20 in this case, million subscribers per year. Okay, now pick a point. Now pick either one of those points. Let's go ahead and use the smaller one. So y minus 130 equals 20 parentheses x minus 2. Distribute the 20, 20x minus 40, and add 130. So 20x plus 90. Now interpret the slope and the y-intercept. Now we just talked about this. The slope is always the rate, which we've already kind of talked about. And the y-intercept is the starting point at whatever given year. So in the year of 1999, right? Yep. So it is 20 million subscribers per year. That's how much it's increasing by. That's your slope. And the y-intercept is, oh boy, and the y-intercept is 90, which means 90 million in 1999. All right. So now it goes on to ask you, what does the y-intercept mean? That was how many subscribers in 1999. And what does the slope mean? It is the rate of subscribers increasing each year. Use the equation to make a conjecture about the number of cellular subscribers in 2015. Well, 2015 is 16 years past 1999. So what you're going to do is you're going to take that equation and you're going to put 16 in for x and get an amount. So 16 times 20 and then plus 90
Tyson Sabers, James Aiken, please come to the office.
is 410, million, no dollar sign, sorry about that. 410 million subscribers. Let me rewrite that because that's bad. Okay, so you can do this last one on your own if you want. It is a little tougher when you have to make your own line of best fit. And check with me on that, and you have your worksheet. So good luck. If you have any questions, please come and see me.